Okay, today let's take a look at um, an introductory lesson on the fundamentals of biology. We'll be looking at just some review from just regular biology, maybe some very, very, very basic chemistry. Um, okay, let's name this the chemistry of life. Alright, well, the first important concept is that, for this lesson at least, is that matter consists of chemical elements in pure form and in combinations called compounds. Um, so, for example, let's bullet point this. So, matter is anything that can take up space and has mass. An element is a substance that cannot be broken down to other substances by chemical reactions. So if you had, say, gold, copper or oxygen, if you keep breaking them down, they won't retain the same properties as whereas they exist in as the normal elements. Let's take a look at a compound. A compound is a substance consisting of two or more elements combined in a fixed ratio. For example, water. Look at water. Water consists of a fixed ratio, 2-to-1 ratio to be exact, of hydrogen and oxygen, and table salt, NaCl, which is sodium chloride. Know that carbon, hydrogen, oxygen, and nitrogen consist of about 96% of all living matter. And just trace elements are elements that are required by an organism in only very small amounts. Hence the name trace. It's only a trace of that existing. Okay, let's take a look at some really basic fundamentals of chemistry. This is probably just a review of possibly 7th grade chemistry even. Okay, elements' properties depend on the structure of its atoms. Okay. Let's get the bullets working again. Okay. Atoms are the smallest unit of an element that still retains the property of the element. Atoms are made up of three different constituents. They include neutrons, electrons, and protons. Protons are positively charged particles. They are found in the nucleus and determine the element. So if you had an element with 50 protons as compared to, say, 1 proton, that could be a difference of, say hydrogen and antimony, something of the like. Neutrons are particles with no charge whatsoever. They're neutral. Neutrons. They are found within the nucleus. Their number can vary with the same element, which results in isotopes. Excuse me. Isotopes. For example, if we had carbon, 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 12 carbon and 14 carbon is the same proton number, but there's different electron number, and that's what causes an isotope, where the electron configuration is different. Or sorry, the neutron configuration is different. So the atomic number is the number of protons an element possesses. This number is unique to every element. So if you had an element such as fluorine and let's say gold, they would have different atomic numbers. If they had the same number, they would have to be the same element. The mass number of an element is the sum of its protons and neutrons.